Yeah, today I'm just going to discuss a few problems that have a bit of an Olympiad flavor because CMI loves Olympiad problems. It's going to be a mixture of a few topics from calculus as well as a few topics you might not have much read about it in your college, but you have heard of it.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI Stat, and CMI MSC Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
A polynomial f of x has integer coefficients such that um, f of 0 and f of 1 are both odd numbers. You have to prove that f has no integer solutions. These are not very long problems. Uh, they are apt problems for a subjective question that appear in the data science exam. So you can try. You have to prove that f has no integer solutions. So you have a polynomial. Let me give you what a polynomial is. So a polynomial f of x looks something like this. Summation ai x to the power I goes from say 0 to k. And so, yeah, and the degree of this polynomial will be k because the last term will be k. And yeah, nothing else. So polynomial is finite. If you have heard of Taylor series or Taylor expansion or something like that, it is indeed a polynomial, but this k tends to infinity. If this k tends to infinity, we say that it's kind of a power series or an infinite polynomial. But polynomial, this k is always finite. So you have f of 0 equals to, you're saying that you said that f of 0 is odd. So in this notation, f of 0 is nothing but a naught, because all these terms, the rest of the terms, which will be a1, 0 to the power 1 plus and so on, they all will become 0. So you are only left with a naught, which is odd. So in this, if you follow this notation, the first statement says that a naught is odd and f1 is also odd. This is the second statement. F1 is odd. This means that a1 plus, sorry, a naught plus a1, 1 to the power 1 plus a2, 1 squared, and so on, goes on up to ak, 1 to the power 2. So all these terms will become a1 plus a2 and so on. That will imply that a1, the sum of the coefficients is 1, sorry, is odd. This is my first implication, which says a naught is odd, and the second implication says the sum of the coefficients is odd. You have to use these two facts, this fact and this fact, and you have to prove that if f of x is 0 for x equals to c, then you will have a contradiction. That means x equal to c is an integer, so c has to be an integer. If fx equals to 0, for x equals to c, where c is an integer, then you have to show that this particular statement will beget a contradiction. So one of the things you can use is, say for example, you have sorry, say for example you have f of x equals to 0 for x equals to c, and c is an integer. So break it down into two cases. C is even, because these are the two possibilities for a integer. C is an integer, that c can either be even or c is odd. Now try to find a contradiction in each of these statements. If you find any contradictions in each of these statements, you will exhaust all the natural numbers, and you can say that indeed this is not possible. So this is something you can use. It's short. I have written them down this part, did this much. The next part, which will actually be the solution, will no longer be this long. So check what happens if c is even. So what do you get if c equals to some twice k equals to 0? You must get a contradiction out of here. You should also get a contradiction if you put c equals to some odd number, which is 0. The contradictions I like, they look similar. If you can find a contradiction out here, you can also find it out here. So you can substitute this twice k out here, because this is what is f of k. So this is f of x. Substitute x with twice k here and see what's, use this fact. A naught is odd, sum is also odd. My first case is c is odd, or c is even maybe. If c is even, okay, note that f of c is 0, because I have considered c in such a way that c is actually a solution of f. Okay, so f of c is 0 and c is even. So we can consider c as some twice k. From here you will get f of twice k equals to 0. If f of twice k, no, let's not get confused with this k and the k from this the polynomial. Say this is twice a. If f of twice a equals to 0, then you will have summation uh, ai twice a to the power I. I will range from 0 to k. This is 0. You have another fact. First fact is a naught is odd. This is my first fact. And my second fact is a naught, a1 up to ak is also odd. So these are the information that we have from the question. So if this is the case, what you can do is, so if you substitute, you'll find that this is a naught plus a1 twice a plus a2 twice a squared, and the last term will be ak twice ak. Okay. So if you see, the whole question is actually a game of even and odds. So this is a very important technique to deal with problems that involve questions, problems that involve statements, say, prove that something is true for all integers, prove that this is not true for all integers. So the main technique you can use here in these kind of problems is break it down into even and odd. The problem reduces to the cases where the a part is even and a part is odd, and you will see that they do not generally follow. They do not generally follow this even and odd thing. So you will find some contradictions. So this is the way you have to, or you can deal with these problems. Always break it down into cases involving odd and even. So the trick here is, so this a naught is odd from here, right? So this is odd. Now if you check, this part is even because it has a 2 in all of them. So this part is even. Okay. So Even an odd number sums up to become an odd number, always. Okay. But according to the question, this is an even number, which is zero. Zero is even. This is not possible. This is a contradiction. It's very simple. You don't have to think anything else. This is a contradiction. So similarly, um, you have f of c equals to 0, and this time I'm considering c is odd. Okay. If c is odd, let then c be twice a plus 1, right? Then you'll have f of twice a plus 1 is equals to summation ai twice a plus 1 to the power I. I will go from 0 to k, right? This will look like a naught plus a1 times twice a plus 1 plus a2 times twice a plus 1 squared, and the last term will look something like ak twice a plus 1. Now this is odd. Okay, okay, leave it. Let's not think about this. Uh, so a general term looks something like this. Right. Now, if you so you don't have to expand it, you don't have to actually expand it, but if you think in terms of binomial expansion, you'll find that the last term is always one in each of them. In each of them, the last term is always one, right? So you can always extract a naught plus a1 out of here from this 1 times a1. You can also extract a2 from this 1 times a2, and you can actually extract a sum of the coefficients, right? And sum the rest of the terms of the binomial expansion. So the rest of the terms of the binomial expansion will always involve a twice a. So because twice a plus 1 whole to the power, say, give me a number, p. This is what? Uh, and c, sorry, it's something like the general term would look like p c q twice a to the power q times 1 to the power p minus q. This is the what a general term would look like. Now this becomes 1. If q is greater than 1, that means if q is the first term or up to the last second term, it will always involve a twice a. Unless the last term where q will, wait, there's a mistake. That's why I got a little bit confused. This will be something like p minus q. This will be q. Yeah. So if q equals to p, unless q becomes p, there will always be involvement of a twice a. That means I can say that there is a factor of twice a in each of them, excluding this a1, a0, a2, and ak, all of this. That means you'll get the sum of all the coefficients plus an even number. Okay. So again, this is a contradiction because according to the question, this is an odd number, this is an even number, and it sums to be 0 because this is 0. So it's very straightforward. Just break it into even and odd and just solve it.
To book a trial class for your preparation courses of IITGM MS, ISIM Stat and CMI MSC Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Stay tuned and stay blessed.